Okay, so first off, we've got the substitution question here. We're trying to integrate this guy here, and it's suggested using u equals x minus 2. So of course we're going to do that. And what we always do is differentiate that. So differentiate u with respect to x, which is just 1. So that means if we rearrange that to make du the subject, du equals 1 times dx, aka that just means du equals dx. Fantastic. And u is x minus 2, so therefore we can put u into there and we can change dx to du. So now if you have a look at it, that means everything is going to be in terms of u, so that's nice. We don't have to do anything extra, so let's just rewrite that over u to the power of 6, right? Cool. And now let's just go across to here so that we've got more space. That's just going to be 30 times u to the power of negative 6. Okay, and so now we can, now we can integrate that. So we add 1 to the power, so it's negative 5, and then we think about what's going to happen. Negative 5 is going to come to the front. We need to times that by negative 6, right? Because now when we differentiate that, negative 5 times negative 6 gives me positive 30. Minus 5 minus 1 is that. So that's definitely right. And then we just substitute u back in. And we're all good. We don't need to bother making that a positive power or anything like that. This kind of one. We're totally fine just leaving it like that. But of course, you could also write it as negative 6 all over x minus 2 to the power of positive 5. Obviously that's the same. And if you look in the back of the book, that's what it'll have, but in the exam you don't need to simplify it. That's absolutely fine. Okay, so we're looking at this one and they haven't given us something to substitute and we can't simplify this fraction, so we then start to think, is this one of those ones where the top of the fraction, the numerator, is the derivative of the denominator? Is it that? So our test there would be to take the denominator, let's call that fx, write that down, and find what the derivative of that is, f dash x, and we see e to the power of 2x, that's going to be e to the power of 2x times 2, and 2x is going to differentiate, so 2. Now we compare that to what's actually on the top, e to the power of 2x plus 1, and we can see that's very similar, only there is just there's a common factor of 2 that's not there. So how are we going to get rid of 2? If we multiply that whole thing by a half, right? The whole thing by a half, that's going to get rid of those 2's and it's going to be the same. So that's where we go, oh, cool. Well, these kind of guys here, where we have the function with the derivative on the top, they always integrate to ln of that function, right? It's that. So that's what it's going to be. Let's just have a look. E to the power of 2x plus 2x. Chuck in the plus c to begin with early. So that's all good, because remember, if we differentiate this, what's going to happen? It's going to be 1 over all of that. Okay, I'm just doing this messily. And then it's going to be multiplied by the derivative of all of that, which is 2e 2x plus 2. And now we can see what's going on. Okay, we don't have 2e, that plus 1, we've got this. So we need to multiply everything by 1/2, because that's going to 1/2 times 2 makes that just 1 times that, and 1/2 times 2 makes that 1. So long story short, that's going to get multiplied by 1/2. Okay, and so there's our answer there. Okay, so the key to figuring this out was recognizing that this was one of these kind of questions. Okay, once we think that this might be one of these kind of questions, then we go down this route and realize what we need to do to adjust it so that it will look how it's meant to look. Okay, hope that answers your question.